Okay, so we're gonna draw Emily over here and Emerson over here. So Emily is going at 12 mph and Emerson at 8 mph. So here's where our relative speed idea comes into picture. And the way to recognize this idea is when you have two objects that are moving. In this case, we have Emily and Emerson moving, so we want to have a relative speed. So since they're both going in the same direction, what we're going to do is we're going to actually hold Emerson still, and we're going to make Emily run. So that would mean subtracting 8 mph from both of them. So that would mean this is 0 mph, and she is 4 mph. Okay, so, and remember there's a half a mile distance in between them, and then Emily needs to get half a mile more ahead until she stops seeing him. So she has like 1 mile she has to cover to, to be not able to see him anymore. So we have 1 mile, and Emily goes at 4 miles per hour. So what does that mean? Emily covers 4 miles in an hour. There are 60 minutes in an hour. So I'm going to put the hour on the top. 60 minutes. And yeah. Okay. So we're going to cancel. Oh. We're going to cancel the hour and the hour. And so it's 4 miles in 60 minutes. And that means 1 mile in 15 minutes. We want Emily to have 1 mile because half a mile here and then half a mile there. So that's a total of 15 minutes in total. Remember, here the key to the question is to remember that Emily, first of all, relative speeds, and then after that, Emily has to go half a mile to reach Emerson, and then half a mile to go past him. So that's a total of 1 mile. So that's how you solve the question. Okay, a little more is like when two people work with each other, how long do they take together? So let's say Harry takes TH hours to paint the wall. Potter takes TP hours to paint the wall. So together, how much do they take? Well, most people just think that you can add the two rates. And that's pretty wrong because if you think about it, when you add the 2 times, it's greater. They basically take more time to paint the wall when they work together. And that logically doesn't make sense because why would they take more time to paint one wall when they work together rather than working individually? And so here's the correct way of going about, working on this question. So if a person PI takes time TI to finish a work, W, then the rate of that person is RI is equal to W divided by TI. And so the net rate at which all of these people work, if there are N workers, for example, is adding all the rates up together. So what you can add is the rate or the speed of the person. You cannot add the times, you cannot add the works, but you can add the rates or the speeds. And so that's a really key thing to remember because if you add the time, it's just logically not going to make sense. And the time T net taken by N people is the work divided by the net rate, which is 1 over the sum of the reciprocals of the times. And this is actually called what is called the harmonic mean. If you remember from the previous lecture, we had a question related to the harmonic mean. So this is definitely a formula that I would remember because it often gets asked. And it's basically the relation between the net time that someone's going to take to, like multiple people are going to take to do something, given the time that they take individually. And you don't have to be given any information about the work they do or their rate or anything. You're just given the time each person takes to do something, and they're asking for the net time. And it's as simple as that. Here's an example. I'll read it and then we'll have some time to solve it and then we'll come back together. Doug takes twice as long as Becky to complete a project. Together they can complete the project in 10 hours. How long will it take each of them to complete the project alone?